Now, there are several ways that you can move and rotate components within the assembly environment to help define their position or locate them. But when I'm moving these components around on the screen, I'm not actually defining their position at all. I'm simply moving them in the work area. That means that even if the components overlap, don't worry, they aren't actually connected yet. To define the position of a component in an assembly then, I'll have to use something called a mate. Think of mates as the 3D equivalent of 2D sketch relations that allow you to add relationships between the 3D geometry of the components in an assembly. To show you how easy they are to put together, I'll center this wheel in the bracket here. Adding a mate is a two-step process. First, I'll need to select the entities I want to mate, and then choose the type of mate to apply. An easy way to access the mate feature is by clicking on the mate icon from the Assembly tab on the action bar. This brings up the mate dialog box, and here you can see that I can select the entities that I want to mate. Working from this dialog box is great if you know exactly which mates you need, but since I like to add mates on the fly, I want to show you how to add mates using the context toolbar. I'll exit out of the mate dialog box and select the inner cylindrical face of the wheel. And then, while holding Control, select one of the inner cylindrical faces of the bracket. When I release the Control key, a Mate Context toolbar appears where I can see the possible geometric relations that exist between these two entities. The available mates include concentric, perpendicular, parallel, tangent, and lock. Note that these available mates will change based on what features, faces, and edges are selected. I'll select the concentric mate, and then select the mate icon to display the mate dialog box, where I can make any additional adjustments as necessary. I'll click the green check. Similar to sketch relations, I can check the degrees of freedom of a component by clicking and dragging on it. I'll go ahead and lock the view rotation. When I click the wheel component and drag it, notice I can only move it from side to side and spin it, but can no longer move it up and down. Now, how can I center the wheel in the bracket? Well, I just need to create an additional mate. I'll unlock the view rotation, and this time I'll select the inside face of the bracket and the outer face of the wheel. And even though I don't have the mate tool active, the mate context toolbar pops up, so I can select a mate type for these entities. I'll select the coincident mate, and notice that XDesign makes it so that the two faces I selected are touching one another. I want to center the wheel, however, so I could delete the coincident mate and then create a distance mate between the entities. But I can save time by simply editing the existing mate. To do this, I'll edit the coincident mate from the Design Manager and change the mate type in the dialog box from a coincident mate to a distance mate. Since I already know the width of these components, I'll set a distance apart of 5 millimeters. And the wheel shifts to solve for the new mate specifications. While this worked, it's important to think about the design intent that you're building into the model as you add mates. What I mean is that although the distance mate here does, in fact, center the wheel within the bracket right now, what would happen if the width of the bracket or wheel were to change down the road? Well, the wheel would no longer be centered, since the distance between these two faces wouldn't update, and 5 millimeters would no longer accurately center the wheel. In the next lesson, I'll show you a slightly more robust, future-proof approach to centering the wheel here.